For the tan function, we just have to be a little bit wary of the difference in the period for tan. So the period of tan is pi. But we still need to do the same things. We want to identify the a value. In this case, the a value is 1. And with tan, it's very difficult to show the vertical expansion. But I'll show you how we can do that. Okay, so a is equal to 1. Our b value, the b value is equal to 2. That makes our period pi over b, which is pi over 2. With our c value, the c value is our horizontal shift. There's no horizontal shift. And with our d value, we can just find another color here to work with. We'll do purple. Okay, so our d value is our vertical shift, which is -1. Okay, so I'm going to first start with my horizontal and vertical shift, and I'm going to just draw in my middle line here. And I'm just going to identify the center where my middle of the graph is going to be. Okay, so once I've done that, I'm going to now use the period. The period is pi over 2, which means then that half the period goes to the right. So that position here is going to be pi over 4, and half the period is going to go to the left. Scale this a little bit better, right about here. Okay, so those are my boundaries. So that's going to be negative pi over 4. That's going to be the left edge of my period, the right edge of my period. And at this point, what I could do is I could probably just sketch it in, and my tan graph's going to go up in this direction and down in this direction. We only really draw 2 quadrants of it. Now, to show the vertical expansion, okay, and you may or may not be asked to do that, but if you were to show the vertical expansion, we show that halfway through the quadrant. Okay, so halfway through this. So this would actually represent the 45-degree point. So normally a quadrant is 90 degrees. Half of it would be 45 degrees. And the 45-degree point, the tan value of 45 degrees normally would be 1. So we can show our vertical expansion and compression using that tan value of 1. So normally we would go halfway and up 1. If it was expansion of 2, we would go halfway and up 2. Okay, but in this case, we only have to go, there is only an expansion of +1, or basically no expansion. And then we do the same. We go to the left, we go halfway through this period and go down 1. So this is going to be at -2 and 0. The x-axis positions of these is going to be halfway in that quadrant. So negative pi over 8 and positive pi over 8. And we can then sketch our graphs through that point. So there's our tan graph, and we just make sure it goes through that point. So that point there is the point that we use as our vertical expansion reference. Okay, we don't always use that, but if you need to show your vertical expansion, you would show it through that point where the slope is normally 1, which is halfway through the quadrant. Okay, so when we're looking at this next graph, we've been given the graph, and we need to put it into an equation. And we're being asked to put it into a sine equation. So to do that, we need to find the amplitude, A. We need to find the horizontal compression, B, the shift, C, horizontal shift, C, and the vertical shift, D. So I'm going to start with the vertical shift. We're going to look at D. So looking at D, sorry, I'm going to do D in red. So that D is going to be determined by the middle line. Okay, so the middle line is going to be +5. Okay, so D is equal to 5 in this case. Once I found D, I'm going to look at my amplitude. The amplitude is then the distance from the middle line to the max. Okay, so we can just count this as the A value is equal to 3. The B value is going to be based on the period. Okay, so the period, if I take a look at 2 points, any 2 points that represent the period. So in this case, I just started at 0 because that seemed to be the easiest. And I showed it in blue here. The period looks like it's 10 pi over 7. Okay, so I can see that the pi value here, they go in increments of 1/7. So this is 10 of those increments, so 10 pi over 7 is my period. Okay, to find the B value, we're going to do 2 pi divided by t. Okay, when I do that, I end up with, looks like 14 pi over 10 pi, so that reduces to a B value of 7. 7 over 5, I think it is. Okay, so there's the pi's cancel out in this case, so the B is 7 over 5. Okay, so once I've established that, then the C value, well, for the C value, what we're going to do is we're going to use the starting point here. Okay, so the middle, since it's a sine graph, we're going to start in the middle. We're going to go start at that position there. So if that position is in increments of pi over 7, so I go 1 pi over 7, 2 pi over 7, 3 pi over 7, 4 pi over 7. Okay, so that position here is 4 pi over 7, and that then becomes my horizontal shift. Okay, so once I have all those parts, I can now write my equation. My equation is now going to be y equals, the A value is 3, sine, the B value is going to be 7 over 5, the horizontal shift is going to be positive 4 pi over 7, the vertical shift is going to be plus 5. So there is the equation of that function. Now there are some formulas that we could use, okay, to calculate the D value. The D value is the midpoint between min and max. So if I want to find midpoints, I can take the maximum value of y, the minimum value of y, and then divide by 2. That's going to give me halfway, which is going to give me the D value. Okay, oops, I did this in the wrong color. That should have been in red. So there's my D value. My A value is half the distance from is going to be the half the distance from the min and max. So if I want to find the distance between the min and max, I subtract. So in coordinate geometry, when we subtract, we get distance. So I want to take the absolute value of that because I want the distance, and then I'm going to take half that distance, which is going to give me the A value. Okay, the period B, let me just move some of the stuff around here. Okay, the period B we can find by taking the period is going to be x min minus x max. Okay, it's the difference between the minimum and the maximum points. So if I find the difference between this point here and this point up here, okay, the distance between the vertices, that's going to give me half the period. Okay, so I'm going to do absolute values because I want distance. If If I subtract those x positions, I get half the distance. And to get the whole period, I just multiply it by 2. Okay, so the distance between, and I'm just going to mark that out so you make sure it's clear, the distance between those 2 points horizontally, that's going to give us half the period, and we multiply it by 2 to get the full period. So we could use these formulas as well, but again, when we have the picture in front of us, we can just work these out as well.